Hi everyone. So, the drawing that we have was based off of the first experiment we did, which was measurements in nanoscale and also indirect measurements of the nanoscale. So starting off in the image, we have a really sick person, and they're really sad because they're sick and they have to go to the pharmacy and pick up their medicine. So the medicine says on it, if you're 6 feet tall, you take 6 pills, and if you're 5 feet tall, you take 5 pills. And the next two images capture the person figuring out how tall they are based off of indirect measurement, which Karen will talk about more. So based off of this, they decide to take 5 pills, and the pills get into their stomach and attack the virus that's making them all sick, and the virus dies, and all the pills and the medicines inside the pills are really happy about this, and then the person's happy again. So, yeah.
Okay, so basically the building and the person is showing indirect measurement. The height of the building and the height of the length of the shadow is being used as a ratio, and then the height of the person can be found because there's only one variable in the next one, like you already have the length of the shadow. So that's indirect measurement, and then the second and third row is basically showing how things that happen on the nanoscale affect things that happen on the human scale, like, yeah, so it changes the appearance of the person. And it also could show, since in the experiment we did, we put oil on water covered in baby powder to show how amphiphilic molecules arrange themselves in a very thin layer. And so the pills kind of self-assembling in a line against the bacteria could be amphiphilic, if you think about it that deeply. Yeah.
Alrighty, so we did really like this analogy. We thought it was fun and cute, but there are a few things that we thought could have been added to the drawing. So firstly, the thing that Karen just addressed, amphiphilic molecules, are basically molecules where one side is hydrophilic, which means they like water, and one side is hydrophobic, which means they don't like water. So if you put them on water, you end up with a layer that's one molecule thick. And we thought this could have been demonstrated through the pills, but it might have been more clear had they actually added a layer of water underneath the pills to show how, for example, the black sides were underneath and touching the water and the white sides were above the water. And second thing we think could have possibly been included is this day we also got to look at a very cool microscope called an atomic force microscope, which basically, instead of using light or electrons reflected through lenses or electromagnetic fields to show really small things, uses what is basically a very tiny finger that actually goes down to the point of a single atom and shows the structure of things on the atomic scale, the nanoscale, by literally moving the finger over the structures. And that was really cool, and we feel like it perhaps could have been included here by maybe showing an examination of the bacteria where perhaps we get a little glimpse into the inside of the bacteria and we see what they look like on the inside through contact with the pills. So we liked the analogy.
All right. Thank you, guys.
Okay, so for everybody, and I tell all of my graduate students this, when you're done, say, "Thank you for listening," because your audience is terrified, paralyzed. Are they done? Are they not done? Will they tell me if they're done? So just say something that says, "Okay, we're done now." You're allowed to clap.
Thank you for listening.
Yeah.
Yay!
That's it. But you're not the only one who doesn't do this. Like, everybody has to be told. Just say, and like professors who've been professors for 30 years still stand up there and then just stop. And then the whole audience just like, wait. Finally somebody claps. Okay, so be smarter than those guys. Okay, so we are open for questions. You don't make me start all the questions.
All right, let's go.
So one of the other concepts that was really big in the lab was the idea of constructive versus destructive interference. Did you guys think of any possible way that within this universe of analogy that could be incorporated?
We actually did brainstorm that a little bit, and the thing we considered was perhaps having the bacteria and the pills represented as two different wavelengths, which is how interference works. So if the wavelengths match, it increases the amplitude of the wave, basically makes it stronger, and if it's opposite, then it decreases the amplitude of the wave, so it cancels it out. And we could have the bacteria basically on one wavelength and the pills on another. So when you have the pills and the bacteria together, that's destructive and it cancels out. If you have too many pills, then that amplifies the effects of the pills and you end up with a stomach ache from taking too much medicine. If you have too many bacteria, then you get sick, as so adorably shown in this analogy.
I have one clarification. Constructive and destructive kind of happens also, like when it's on like the same wavelength, but like when the troughs and the peaks kind of meet. So yeah, that was just one clarification. That's it.
I think you'd have to be a really good artist to describe what you just described, because that's a hard concept. I don't think I would ask for you this question, because I don't know how I would add that to a figure that already has a whole lot of concepts in it. But just for everybody, the simpler the concept is, the more likely people are actually able to get it out of a cartoon. So it's almost impossible to make really complicated concepts in a drawing. I'm not sure. I don't think I have an answer to Rita's question.
I'm not sure if I do either, but I was just curious if they thought of anything.
That's a lot of our time of brainstorming with like no results.
Yeah.
So, yeah.
That's okay.
So I understand the indirect measurement approach shown in the drawing. Now, in the description of the experiment, you talked about a special microscope that used like a probe that went down to 1 atom width. How did you actually do the indirect measurement in the course of the experiment? What equipment did you use?
So we didn't actually use the microscope in the experiment. That's a really big, expensive piece of equipment that we just got to look at because we're kids and they don't want us messing with it. So in the experiment, what we did is basically we had a tub of water and we put a really thin layer of baby powder on the surface, and then we put a drop of oil on top of the water. And because oil and water don't mix, it formed a very thin, 1 molecule thick layer on top of the water. So if we could measure the diameter of the circle formed by the oil, and we knew how much volume was in it, then we could calculate the thickness of the layer based off the volume and the diameter of the circle, which gave us the thickness of 1 molecule, because the layer was only a molecule thick, and then we just assumed it was a perfect circle because we don't want to do complicated math, and then we could calculate the size of 1 oil molecule. So,
What was the baby oil?
So the oil was just like vegetable oil, and then the baby powder was so we could see the difference between the oil, where the oil was and where there wasn't any, so we could measure the circle.
That was a good description. So when you are presenting these things, do remember that your audience has not done the experiments, and so just like that, give them some fill-in of what the experiment actually is when you're giving them the analogy. That helps a lot. Okay, any more questions? One more question? Okay, I'm going to ask a question. So the ratios and heights of shadows and things is actually a pretty good analogy with this kind of geometric indirect measurement. What's the fundamental problem with it? What do you usually not know? You're trying to get the height of a person. But what do you need as inputs? for this particular measurement?
Well, you need measurements of like, could you,
So you need to measure the surroundings of the person to figure out the height of the person, but when you're working on the nanoscale, you can't take measurements of the surroundings of things. So you have to be able to work from the outside in to calculate size, and this is really just working from like left to right.
You need to know a lot about the surroundings, particularly you need to know the height of a building, which is not necessarily so easy to do. But the concept of that kind of indirect measurement is actually a very good analogy. Okay, any other questions? All right, let's thank these guys for a really nice presentation.